Today we're going to start our study on the physics of fluids with the topic of fluid systems. And systems typically have properties that are determined by the interactions or the intermolecular forces and the properties of their constituent atomic and molecular substructures. So for example here, we have H2O or water as a liquid. Well, the interactions are going to be due to the hydrogen bonds. Okay, so you're going to get those dipole-dipole interactions, as you'd see if you took chemistry. Whereas with a gas, so such as hydrogen gas, for example, well, the interactions are going to be due to the London dispersion forces between these molecules. Okay, so when we refer to fluids, we refer to liquids and gases. Now, to actually model fluids, we don't really consider the interactions of the individual molecules or atoms in the system. Because if we take enough of these, so effectively we look at the bulk behavior and average out the properties of the substance. So for example with water, so you'll see it like a homogeneous liquid at the macroscopic scale, and therefore we can treat it as an object, just like we do with any physical object. So let's look at an example. Now suppose we had a block here, and part of it is submerged in that liquid. Well, there's going to be a force of weight acting on that block, which is going to pull it downwards. And there's going to be another force that's causing this block to float in the water. And that's the buoyancy force. And this force of buoyancy is calculated using the submerged volume of the block, as we'll see in subsequent videos. Now another example is a fully submerged block. So in this case the fluid is going to exert contact forces on that box. And these forces become larger with an increased depth of the block in the water. So as you can imagine, the more water you have on top of the block, the larger the forces are going to be. And of course we'd have the gravitational force also acting on that block to push it downwards. And in reality you'd have this in 3 dimensions. So for example, if we're looking at the block, it's actually 3-dimensional. And those contact forces from the fluid on the block are going to be acting effectively in 3 dimensions. Okay, so what we'll have is something like this. And we'll have another larger force at the bottom of the block. Okay, so what it looks like is something like this. And then you'll have another 2 forces going in and out of the screen. And we'll look at these free body diagrams in more detail in subsequent videos. But effectively we're treating the fluid as an object. And this will enable us to use Newton's second law to model the fluid and the forces it exerts on different objects. And I'll see you in the next video.